So this is just a bit of a tongue-in-cheek visual. So I'm really just kind of demonstrating historically how we think about our fields versus what I'm proposing how we should start thinking about our fields in the future. So on the left here we see like this is traditional agriculture. We've got a quarter section. We treat that quarter section all the same. We give it possibly a yield goal. We might have a single composite soil test on it. We're building a fertility recommendation for that entire flat rate blanket applications on that quarter section. If you look at my right, this is to me kind of summarizes what we're doing in the future. And so we're taking that same field, but we're splitting it up into a whole bunch of small fields, right? So in this case, this field, what would typically be 160 acres is now about 1,900 fields at just less than a tenth of an acre. So each one of those blocks, and I've got this on my presentation here, but at each one of those blocks, they get a unique yield goal. They get a soil analysis. We know at each one of those blocks, we're taking substantial amounts of soil samples and interpolating this across the field so that we know that each one of these blocks, what soil test characteristics represent that little block. It gets a unique fertility recommendation based on the yield goal and those soil tests. And then we go through a process of analysis. So we analyze cost per bushel of what it took to raise a crop in each one of those blocks. And we are able to layer yield data over and do correlations on each one of those blocks. So it's about taking what would be typically managed as 160 acres, and let's just turn that one big field into a whole bunch of small fields. The other thing I want to point out here is that our recommendation is a result of the spatial yield goal, identifying different yield goals within a field, and then using the underlying soils data to inform what fertilizer and how much fertilizer we should be applying. The important thing that sets us very much apart here is that these are all independent data layers. So if you're getting a yield potential map from primarily an imagery type VR company, you get one map, right? They're not able to tell you, well, this is what your soil pH looked like, and this is what your soil phos distribution was, and this is how your organic matter varies across the field. They can't tell you any of that. You get one map, and your phos recommendation and your nitrogen recommendation, they're going to look essentially basically the same. Obviously the values are going to be different, but the spatial changes throughout the field are going to look exactly the same. We know that's not the case, and that's why we've gone down the route of this a substantial grid sampling event here. So what's different? How does this differ between some of the other offerings on the market? We're relying on real data. Application data, yield data, cost data. There's a reason the other folks in this market aren't doing that, and it's because it's a ton of work. But we feel that the only way we could look our customers in the eyes and tell them with confidence that we were moving the needle in the right way, and we needed that real data to quantify that. So dollars and cents analysis. So looking at your field through the lens of cost per bushels, understanding, in this field, long term, we start to be able to think, in this field, in 5 years, how often does this portion of the field make money? We're going to continue to improve our approach. We're going to continue to improve our rationale for making management zones. We're going to continue to improve how complicated our soil equations are. And then really, at the end of the day, it's all agronomy, right? This service is going to make us better agronomists.